Okay, welcome back to trigonometry. We are going to continue talking about inverse trig functions. So here is the idea. So again, to remind us that an inverse trig function, okay, so a trig function takes an angle and maps it to some kind of a ratio. Okay, the inverse trig function goes ahead and takes that ratio, just using sine, for example, okay, and maps it back to the angle that would give this to us. Okay. Now, so these are inverse functions, but we have to remember that the domain of these things is a little bit restricted because for sine, right, we are going to be looking at between negative pi over 2 and positive pi over 2. So my angle must be between negative pi over 2 and positive pi over 2. For cosine, right, so for we have theta equals the inverse cosine of some kind of a ratio. We're going to get back to our graph here. So we're going to be looking at our cosine. It's going to stop from here to here because, again, we don't want to violate the horizontal line rule. So my theta for tangent here is going to be between 0 and pi. For, uh, inverse tangent, so we have theta is equal to the inverse tangent of some ratio, okay? And with tangent, since we are going pretty much from negative pi over 2 to positive pi over 2, um, our theta is going to be between negative pi over 2 and um, positive pi over 2. The inequality is a strict inequality, so it's greater than, less than, because we don't actually ever get to pi over 2 because that's an asymptote. Whereas the other points, like, yeah, it's fine. You take cosine of pi gives you -1. Inverse cosine of pi will spit you back -1, or spit you back pi. Okay, so for sine and cosine, inverse sine and inverse cosine, they could be brackets. For tangent, they're going to be strict inequalities for this one. Okay, so let's go ahead and take a look at a little bit of a note. So the first thing I want to do is say something like, well, um, they don't always give you the angles that you actually want. So, for example, let's see if I can find an example I was looking for you here. Where are we with this guy? Oh, this goes too far. Don't want to go that far. I need to go less. Okay. I would like, okay, I want to say, what is the inverse sine of, and we'll go ahead and we'll say negative square root of 2 over 2. Okay. Now, this is going to give us, okay, negative pi over 4 degrees. Okay. So I want you to remember, like, if we have the sine of negative pi over 4 degrees, then the answer is going to be negative square root of 2 over 2. So it would make sense that the inverse of negative root 2 over 2 is going to give us negative pi over 4. However, I want you to think about this because the sine of, say, 3 pi, no, 1, 2, 3. Let's go with 3. Let's go with 5 pi over 4. Okay, it's a third quadrant kind of a thing. That's going to give us the negative square root of 2 over 2. If I take the inverse sine of negative square root of 2 over 2, it's not going to give me back 5 pi over 4. It's going to give me negative pi over 4. So I want us to be really cognizant of the fact that the sine of the inverse sine of, say, well, actually, let's go with this. Let's go with the inverse sine. Let me go ahead and redo this again. So I'm going to ask you for the inverse sine of the sine. Okay. The inverse sine of the sine of 3 pi or 5 pi over 4. Okay. Usually, and this is pretty much, I'm trying to set this up so it looks like the inverse function of the function of x should be equal to x. Like, that's a thing that we taught you in pre-calculus, and that's not necessarily true for these cases because there's restricted domains. So we have to work from the inside here, get what's going on here, and then pass this ratio to my inverse sine function to get the actual angle that it's going to expect here. So you always have to work from the inside out. So what I'm going to do is I want the inverse sine of what is the sine of 5 pi over 4? You're like, well, that's just negative. That's square root of 2 over 2, negative. And when I pass negative square root of 2 over 2 into inverse sine, it spits me back an angle, and that angle is going to be negative pi over 4. Okay, so it is not just automatically going to give me the argument that I passed it. Okay, you have to go through the inside out and actually work through this thing. Otherwise, you're going to get wrong answers with this thing. So don't just take it on advanced faith that it's going to be like, well, inverses and functions undo each other, and I don't have to think about it. I just go ahead and deal with it. I'm like, that's not how this is going to work. Okay, so we have to think about how that's going to work. So if I do this one, if I do the inverse cosine of the cosine of, say, I want to go with 2 pi over 3. Okay, where is 2 pi over 3? Well, 2 pi over 3, second quadrant stuff. Okay, so remember we have all students take calculus, the second quadrant, cosine of 2 pi over 3. What is my reference angle? My reference angle is pi over 3. So cosine of pi over 3 is going to give me 1/2, but cosine of 2 pi over 3 is going to give me negative 1/2. Okay. And please check me on the calculators to do this. I'm using on radians here, but 120 degrees. Cosine of 120 degrees is, check it out, it's negative pi over 2. We want to then pass the negative 1/2 into the cosine, right, and get an answer. And again, because how this thing works, we actually are going to get 2 pi over 3 in this case because inverse cosine will go from 0 to pi. Okay, if I pick a angle in the fourth quadrant, right? So if I take inverse cosine of the cosine of, say, um, let's go with we have 1 pi over 3, 2 pi over 3, 3 pi, 4 pi over 3, 5 pi over 3. Okay, so we don't have to change reference angle. So I want the cosine of 5 pi over 3. Okay, so the first thing we're going to do is pass cosine 5 pi over 3, and that's going to give us, so I want cosine of 5 pi over 3. It's in the fourth quadrant. I'm going to end up with 1/2, and you're going to take the inverse cosine of 1/2, and it's going to give you pi over 3. So these are different. They are not the same angle. Okay, so we have to remember the restrictions on this thing, and the reason why we have to remember that is because a lot of times I'm going to pretend to take the cosine of both sides or the sine of both sides so that it's easier for me to think about, easier for me to put things in a triangle. But I know that I'm squinting while I am doing this because I know that this is not going to give me a good answer because of this issue right here. Okay, so it's something we have to remember that we're taking this cosine of both sides and it doesn't quite undo things. It just kind of undoes them. Okay, so what am I talking about? All right, so that's a thing we have to remember to go ahead and deal with. If a lot of folks turn into engineers, which is fine, and most of the time engineers deal with angles in quadrant one, and this will never come up in quadrant one because all the angles are positive, and we don't have to worry about this. Where are we on the circle kind of an issue? But in this class, this does come up. Okay, so we have to be careful about where we are and what quadrant are we in and how are we actually dealing with this thing. Okay, for a lot of inverse functions, I think it's appropriate to use degrees rather than radians, just because it helps us visualize it a little bit better, so don't feel bad about that. Um, if there are any kind of crazy angles, using degrees is just fine. Okay, if it's a nice angle or a nice number that you should know how to do, they'll probably put it in radians and expect that you would have recognized this from the radians. Okay, so one of the examples that we like to do here is there's a set of problems that we would look at, and we would say, okay, what is the sine of the inverse cosine of the square root of x squared minus 4 all over x? Okay, and we have to think about how that's going to work. So how we're going to do this is kind of a two-part problem here. So I could think like I want theta to be my inverse cosine of the square root of x squared minus 4 all over square root over x here. Now, I have a hard time visualizing my triangle as what's going to happen here. So what I'm going to do is I'm going to take the cosine of both sides is equal to, and I'm going to say this is the cosine of the inverse cosine of the square root of 2, x squared minus 4 all over x. Now, I know that this doesn't actually cancel it out, but I'm going to pretend it does just for the sake of being able to draw my triangle. Okay, so it does in certain areas, but it doesn't in all areas. So we have to be careful when I'm doing this. I'm not really taking the cosines of both sides. This is just a device for me to use to kind of set up a triangle so that I can solve this problem. So we're going to say we have cosine theta equals x squared minus 4 all under a square root divided by x. Now, the real goal of this problem was I wanted the sine of this angle. Okay, but can we draw a triangle? If I have cosine of theta is equal to some ratio, could I set this up as an adjacent over hypotenuse? Right? Because remember, that's what cosine is. Cosine is adjacent over hypotenuse. So we could say, oh, this is the square root of x squared minus 4. Just taking the adjacent side, divided by my hypotenuse. Now, the question is, this is a right triangle. What the heck is this opposite side? Because I'm going to need that for sine. So we have to go ahead and figure that out. So we're going to say, okay, we have a squared plus b squared is equal to c squared. Let's go ahead and see what that's going to do for us. So we have the square root of x squared minus 4, right? Squared plus b squared, which we don't know, equals c squared. That's going to be x squared, right? We're going to square this x. So we have x squared minus 4. We squared the square root plus b squared equals x squared. Go ahead and subtract the x squareds from both sides. So we have negative 4 plus b squared, okay, is equal to 0. Oh, I guess b squared is equal to 4. B is equal to 2. Okay, we're going to pretend everything is in the first quadrant the way we drew it here, technically plus or minus 2, but we're going to go ahead and say it's 2. Okay, so we're just going to take the principal square roots for these things so we can go ahead and figure this out. Now, as I'm looking at this angle theta here, what is the sine of theta? And that's going to be opposite of our hypotenuse. That's going to be 2 over x. And that's my answer for this whole problem. So it's kind of like a two-part thing where we have to take apart the inside of this, figure out the triangle in order to figure out the outside of it. And all of these problems work effectively the same way. So let's see if I can find a couple of examples here, kind of see what's going to be happening with us with this one here. Okay. So let's see here. We want, okay. I have a bunch of problems that look a lot like this. Let's see if we try this one. We could say we have the sine of the arc cosine. Okay, that also means inverse cosine of the square root of x squared minus 9 all over x. And then, yeah, we can probably kind of figure out what this is going to look like and real quick. But let's go ahead and draw the triangle and do this really carefully. So I'm going to say that theta equals the arc cosine of the square root of x squared minus 9 all over x. Take the cosine of both sides. Sort of. Okay. So we're going to say that cosine of theta is equal to, I'm taking the cosine of the arc cosine, that's going to cancel it. Cosine of theta is equal to x squared minus 9 all over x. All right. So there we go. Now, can we draw a triangle here? Okay. One of the things I love about trig is back when I took it, when this was my first college class, pretty much the advice that the teacher gave us was, we come to it, we'd say, we're stuck. Like, did you draw the triangle? No. So, why did you draw the triangle? I'm like, oh, this is easy. Like, yeah, that's how this works. Okay. That's the nice thing about trig. It's like, it's the study of triangles. Let's draw a triangle and figure some stuff out. So here we have our a squared plus b squared is equal to c squared. We're going to go ahead and plug some things in. So we have the square root of x squared minus 9 squared plus, I don't know what b squared is. I don't know what this is yet, equals x squared. So we pretty much have a very similar dance that we just did in the last problem. So we have b squared is equal, well, we have b squared. Let's go ahead and do this one step at a time, so I'm not going to get ahead of myself here. So let's go ahead and say that. So we have x squared minus 9 plus b squared equals x squared. So this is minus 9. So we cancel out the x squareds because we subtract an x squared from both sides. And we'll have minus 9 plus b squared equals 0. B squared equals 9. And again, just like the last time, we're going to take the principal square root. B equals 3. So on my opposite side here in my triangle, we have 3. Now, the whole goal of this was I wanted to figure out the sine of this angle. So we're going to go back to this. We're going to say, oh, the sine of this angle is equal to 3 over x. Okay, and that's going to be my answer for this. I'm looking for an algebraic expression for how this is going to work. Okay, and that's pretty much what the whole deal is here. Okay, so let's go ahead and we'll see about this. Let's go ahead and we'll do the tangent. We'll do the arctan. So we want the what do I want to do here? I want the oh, there's one. Okay, let's do the cosecant of arc cosine of x squared, square root of x squared minus 16 all over x. Okay, so we can go ahead and figure out this thing. So again, we don't want that. We want the cosecant. Let me go ahead and change my thing here because it's asking you for, oh yeah, it's cosecant. We're there. Okay, we're good. So again, inside out here. We'll work from the inside pieces to the outside pieces. So I'm going to say theta equals the arc cosine of the square root of x squared minus 16 all over x. Take the cosine of both sides. So I have cosine of theta equals x squared minus 16 all over x. Now, I'm going to draw a triangle because cosine is adjacent, right, over hypotenuse. And again, I have to figure out this b value here, okay? So we're going to say that we have a squared plus b squared equals c squared. We're just going to plug some stuff in. A for adjacent side, okay? So we have the square root of x squared minus 16 squared plus b squared, I don't know what that is equal to c squared x squared. And we'll go ahead and sort this out. So we have x squared minus 16 plus b squared is equal to x squared. Go ahead and subtract that x squared from both sides, right? So we have negative 16 plus b squared is equal to 0. B squared is equal to 16, and hence b is equal to 4. So I go back to my triangle, and we're going to say, instead of b, we're going to say this is 4. Now, what did I want? I wanted the cosecant of this. Okay, so the cosecant of this theta is equal to, well, cosecant is 1 over sine. That's opposite over hypotenuse. This is hypotenuse over opposite. We'll just read it off the triangle. So this is just going to be x over 6. And that's all you had to do for this one. Okay, so that's it's like we're figuring out some algebraic expressions for arcsine or cosine. A lot of these problems you guys will be able to use in your calculators. It's just that you have to be careful when it says to you, hey, by the way, this is in a different quadrant, so we're going to have to figure this thing out, and we're going to have to do it that way. So you're going to use your mnemonic of all students take calculus, students take calculus in order to figure this out. So let me go ahead and give you this one right here. Let's go ahead and say, okay, I would like to know what, let's see. I would like to know what theta is equal to the inverse tangent of, let's go with, I think it's definitely in not a good quadrant for us. So we're going to say we want, um, I'm going to say 5 pi over 6. All right. But I am going to say that theta, right, is going to be between 180 and 270 degrees. It's going to, I want to know, like I'm specifying that, by the way, this angle, okay, let's change our answer here. Okay, I wanted to say this is going to be, I want negative square root of 3 over 2, negative square root of 3 over 3. Okay, that's what I'm trying to think here. Okay, so we want inverse tangent of square root of 3 over 3, but we're going to specify that inverse tangent, the theta is between pi and 3 pi over 2. So one of the things that I'm going to do is I'm going to strip the negative sign off of this. Okay, I'm going to say theta is equal to the inverse tangent of square root of 3 over 3. This is not going to give me an angle. This is going to give me a reference angle. And then we're going to figure out what we're going to do from that reference angle. So we can go ahead, I would say set your calculator to degrees and go ahead and do this. And you're going to get 30 degrees here. Okay. So we have our reference angle to be 30 degrees. Now, if you just go ahead and say, okay, plug it in here for negative square root of 3 over 3, you're going to get negative 30 degrees because it's going to put it in quadrant 4 because that's where arctangent tends to live. We don't want it in quadrant 4. We want it in quadrant 3 because we were told theta has to be between pi and 3 pi over 2. So we know the reference angle is 30 degrees. What's the actual angle whose reference angle is 30 degrees, but that angle is in quadrant 3? Let's say, wait a minute, that's going to be 180 plus 30 degrees is equal to 210, or we could say this is going to be 7 pi over 6, okay? So my theta, depending on how they give it to you, but usually with these kinds of problems, unless it's one like this where somebody was very careful to make it up as a nice thing, you're not necessarily going to have to do the radians. They'll probably be okay with the degrees unless they state otherwise. Okay, but we can convert if we have to. All right, so we're going to get theta is equal to 7 pi over 6. If I go ahead and type in tangent of 7 pi over 6, I will indeed get square root of 3 over negative square root of 3 over 3. And that's pretty much how you do these kinds of problems. So to do these kinds of problems where you're trying to figure out like theta, you're trying to figure out the angle in like an arbitrary position, I would say take it from the first quadrant first, right? Do the first quadrant, but understand that you are finding a reference angle and then apply that angle in the appropriate quadrant in order to get the right answer. Okay. So I know it's a little tricky and it's a little sticky in order to have to do that, but that is the nature of how these problems tend to work. Okay. So I'm going to say thank you very much for watching, and I will see you in the next video. Take care.